The next equation that we will look at is the non-homogeneous equation. Non-homogeneous equation is an equation where your fx is not equal to 0. The solution for this type of equation is given by the combination of YH and YP. Okay, so this is the YH solution, the one that we have learned in the previous video, and the second one is YP. So there are two methods that we can use to determine the YP. Alright, this YP. The first method is the undetermined coefficient, and the second method is the variation of parameters. Now let's have a look at the first method, which is the method of undetermined coefficient. This method, it has a limitation because only 3 types of functions in fx that we can use to solve to use the method. Okay, so the first method, the first case that we can consider to use this method is when the fx here is a polynomial. Okay, when the fx is polynomial, we can use the method of undetermined coefficient. The second case is when fx is exponential. We can use the undetermined coefficient. The third case is when fx is either sine or cosine. Tangent is not included in here, alright? And the fourth cases is if fx is the sum of all the cases that we have above. Okay, remember, undetermined coefficient, we can use the polynomial, we can use the exponential, we can use for fx sine or cosine. Only for these 3 types of function we can use this method. Now let's have a look at the first case where your fx is polynomial. So when the fx is polynomial, we can guess the yp, okay, by using this formula. Okay, try yp equal to x with the power of r, and then the polynomial equation with the same degree with fx. So if fx here, it has the degree of 2, okay, like x squared plus x plus x squared plus x, okay, equal to 0, for example. Then the yp here will also have cn x with the power of 2, okay, plus c1 x with the power of 1, and so on. Alright. Now, note the x with the power of r here. Okay, we always start with the smallest r, which is r equal to 0. So it means that it will become 1 actually. And then we can compare whether we have the same terms in YH that is similar to YP or not. If there is similar term, then we have to increase the value of r from 0 to 1 so that the whole equation will be multiplied by 1. And then check again whether there is similar term with YH and YP. If not, then we can continue with the solution. Now let's have a look at the example. Given a differential equation in this form, and we can see that this is actually our fx. So to find the solution, we know that this is given by the combination of y homogeneous plus with yp. So first of all, find what is y homogeneous. Okay, and remember this y homogeneous comes from fx equal to 0. So basically we will have a differential equation like this, which later we can reduce to a characteristic like this. Okay, characteristic equation m squared plus m minus 2 equal to 0. And this quadratic equation, we can do the direct factorization. No need for us to use the formula. It's so simple. You want to cry, right? So easy, right? So when we do the factorization, we will have m minus 1. This is minus, not plus. So please do the correction there. Let me check whether I can do the correction or not. Yeah, let's try this. Let me erase this and use minus. Like that. Okay. So we have here m minus 1, m plus 2. And that will give us two distinct roots. Negative 2 and 1. Since the roots are distinct, we know that the equation that we should use is this one. Okay, YH equal to AE negative 2x plus BEX. Okay, we have two different roots like this. Now, that's done on one part. We have to continue with the second part, which is to find what is YP. Alright, so first of all, let's look at the formula. Where is the formula again? It's on top there or here. Okay, look at the formula and we see that the fx, let me write down the fx. The fx has the degree of 2, right? The highest degree is 2, right? This one. So that's why when we want to guess the yp, okay, first of all we have to guess. We will start with the highest degree, which is x squared as well. And we have the coefficient of C2, and then here we have a coefficient of C1x plus C0 x0, actually x with the power of 0. So it becomes C0, C0. And then this is actually has the multiplication with x with the power of r. And since we start with r equal to 0, so we have x with the power of 0. Now, let's compare between this YP and this YH. Is there any similar terms? One here is the exponent. This is also exponent. And in YP, do we have the exponent term? No, right? Okay, so since there is no similar terms, we can proceed with the solution. Okay, so it's no similar term. Alright, if yes, then you have to modify by adding the r by 1. Okay, so we will multiply the whole equation with x. But however, in this case, it's no. So we can proceed to find what is yp prime and what is yp double prime. Okay, so what we do? Just differentiate this yp. Okay, differentiate this. We get 2c2x plus c1. And differentiate this again, we get 2c2. So the next step is to substitute the equation here, okay, equation number 3 and number 2 here, this one, into the differential equation, this one, the original differential equation, so that we can compare with our fx here. Okay, so let's do this. It's already inserted there. So this is our yp double prime. And this is our yp prime. This is minus 2. This is yp. Okay. So you can see that this is actually the differential equation formula that we have, right? Y double prime plus y prime minus 2y equal to fx. So this is the same one. Y double prime plus y prime minus 2y prime and y equal to this fx. Okay, so we can rearrange the equation. Okay, see everything with x squared, you can put them together. This is x squared. Everything with x, so this is x. You can arrange them together. And everything with the constant, you can put them together like this. Okay, let me arrange. Let me sort it. We will have with x squared, we will have negative 2c2, okay, coefficient for x squared, and then plus with coefficient for x, the pink one, we have 2c2 plus, no, minus 2c1, this is x, And lastly, we have 2C2 minus 2C0. Okay, the blue color. And equate this with 2x squared minus 4x. So what do we do next is we can compare, okay, the coefficient for x squared here, this one, with the coefficient for x squared there. Okay, and the pink one for the x, coefficient for x, we can compare with the coefficient for x here. And the last one, the blue one, okay, on the right hand side we cannot see, right? But it is actually plus 0. Okay, so if we compare, it is equal to 0 actually. Okay, so that's why we will have, okay, if we take the coefficient for the x square, we will have negative 2 C2 equal to 2. So that's why we got C2 equal to negative 1. And then we have 2C2 minus 2C1 equal to negative 4. Right? And then because we already know C2 equal to negative 1, is it? So we can have negative 2C1 equal to negative 4 minus 2 times negative 1. So from there we can get what? Negative 2 divided by negative 2 equal to 1. Right? And the last one we have 2C2 minus 2C0 equal to 0. Then we have C0 equal to C2. And what is C2 again? Lupa. Cerita betul je. Oh, I forgot to include the C1. Ayo. Let me correct this. Okay, 2C2 plus C1 times C1. Okay. Minus 2C0. Alright, so let me write this again. See, I made mistake. So you have to be careful next time in the exam when you look at the coefficient. Please be careful. Okay. So C0, negative 2 C0 equal to, now we can just rearrange it in this way. Okay, 2 C0 equal to 2 C2 plus C1. So what is C2 again? C2 is negative 1 plus 1. So we got negative 1, negative 2. So negative 1. So C0 equal to negative 1 over 2. So that's why we get the solution. So once we determine what is the C0, C1 and C2, now we can substitute this into YP. Right? Remember this YP? The one that we originally guessed. So this is our YP. And don't forget that the final answer is the combination of Y equal to YH plus YP. So what is our YH again? Just now on the top, we already have the YH, right? Okay, so YH we have this Y equal to AE negative 2x plus BEX, okay, minus x squared plus x minus 1 over 2. Okay, so this is our YH and this is our YP. That's it. So easy, right?